Our first talk today is from Yingfu from Statistics Sweden, and he's going to speak on model selection in an annual review, a machine learning inspired approach. I'll turn it over to you, Yingfu, and you can share your screen.
Hello, everybody here. Can you see my screen now?
We see it. It's not in the
I can try it again. Is it okay now?
There it is. Perfect.
Dear colleagues and friends, today I'm going to talk about common problem in seasonal adjustment. It's about how to select model during annual review, and our idea to use a machine learning approach. The idea is very basic, and it's an ongoing work, so I appreciate any comments and suggestions. You know, there are different revision policies in seasonal adjustment, how often we will update our models and coefficients and so on. I will not go into the detail about those choices, but just to mention that the partial concurrent adjustment is recommended by Eurostat, by the European statistical system. It means that at some time point we find the optimal model for different series, and then we will keep the models for the coming year, and we will then update the coefficients for any new observations. After 1 year, then we will going through the seasonal adjustment models to see if the model is working properly after 1 year, 12 months, or 4 seasons, the 4 quarters. This practice is a good trade-off between accuracy and revision errors. It's why Eurostat recommends this choice. So in our office, common practice is like during an annual review, we try to find different models. Here, the choice for the lace industry 7 and 8, we use the current model along with the best 5 models from X-Torv ARIMA. And for different models, we can collect different diagnostics to help us decide which model is working best. One point here is why not just use the Bayesian information criteria BIC here, as we used in some in X-Torv ARIMA program. One problem is that the BIC doesn't take consideration of how many outliers we identified in this model, and it doesn't take account the revision either. So we can not really solely rely on BIC. So our goal is try to automatize this process, because it takes it takes quite a lot of time. And at our office, it takes several hundred working hours to going through this annual review for those surveys that the seasonal adjustment is carried out. Besides, this process is quite boring too. So it's not mathematically stimulating. So we try to find somehow a process that make this procedure automatic. One way is to try to rank and weight the different diagnostics such that we can have one single criteria for the choice. The ranking, for example, we can do in different ways. We can rank the different diagnostics and somehow combine those rankings. But one problem for this method is that we generally don't have a true model, and we don't have a single criteria that can be used to make our final decision either. So here comes the machine learning procedures. You may know that in particular for supervised machine learning, we have to label the targets with the true value in order to do classification or other tasks. Then we think why we cannot use our selected model as the true model in the beginning, because we think that our statistician has most experience. So we have to. For myself, I have done this for like 10 years every year. So our choice in some sense should be one of the best one. So if we can accept, we are allowed to do it. Then, for example, we can choose some weights to different diagnostics. For those weights I list here, so the accuracy rate will come about 60%. It's different, maybe different agency and different statistician have a different criteria. So it might not be any single choices. But here for us, as I said, if we can accept that assumption, so we can go further and naturally continue is to search different combinations of the weights for diagnostics, and then we can try to find the best weights combination that the accuracy rate come as close as possible. And we can also use the common practice in machine learning to split our data set with two parts, one as training data set and another one as test. So we have something to evaluate if our choices are not either not overfitting nor underfitting. as I said, it's the idea is very simple, and it's a rather new idea we have obtained. So the result is very preliminary. It's incomplete. The results are incomplete. I have split the 75 as the trained data set and the 25 as the test sample. So the accuracy rate for the training data set is 78.5%, and the test data set, the accuracy rate is 76 to 85% about. The accuracy rate is somehow lower as I expect. I guess because we have to investigate the results more, but I guess somehow it depends on humankind weakness. For example, I may have made the judgment inconsistently because it's difficult to say how many revisions can be trade off with the worsening of some of the other diagnostics. So it's a quite empirical and based on different experience. So another problem we found from preliminary results are there are no unique solutions. It's not strange because what in this case what we are going to optimize is how many time series the algorithm will choose the same model as we have chosen. So it's the optimization space maybe not convex, and there are no further than optimization grids for different weights are not continuous either. Because we choose only 1 to 10 for in this preliminary test. Of course, it's arguable if we can assume that our choose the model are the true model or the optimal model. But anyway, it's just a test show that the traditional statistical learning can be benefit from some ideas from machine learning. We talked quite a lot in our office how to use machine learning and other techniques to help official statistics, and there are many problems. Maybe we can use machine learning to help us. So it's a very simple practice and study. So I appreciate really your comments and suggestions. There are many questions we still have. So if you're welcome to ask now or discuss now, or you can email me. Thank you.
Thank you, Yingfu. We have some time. Does anyone want to enter this discussion? Anyone else using machine learning for automatic modeling or have other suggestions or thoughts? I think you should be able to unmute yourself if you want to enter the discussion, or you can type things into the chat, either way.
I would have a comment to add. I'm not sure if you can hear me.
Yes, I do.
Hi, Yingfu. It's Steve
Hey.
from Stats Canada. How are you today?
Fine.
Good. I just wanted to mention that we've been thinking about a similar idea to sort of save some resources that we typically spend on selecting models and trying to automate that side of things. Yeah. Where we ran into a big struggle was trying to agree as a group on the weights and the diagnostics that should feed into the objective function kind of thing.
Yeah.
So we've kind of stepped away from that work, but I think where we left it was we were thinking of those weights maybe being parameters because they might vary based on the context of a given program. So that's kind of where we left off, but I'd like to reach out to you on the side and maybe we can discuss in more detail.
Yeah. Thanks.
Thank you, Steve. Does anyone else have any thoughts that they want to weigh in? We have a couple minutes. So.
Yeah, I wanted to ask one thing. This might lead into my talk as well. Do you have any outside advisors or any encouragement of other people who are not part of your agency to participate in your annual review? Has that ever worked out?
To ask some others to participate the annual review work?
Yes, that's what I'm asking. Do you have an outside advisory panel? Have you ever tried that type of a model or that type of
No, not really for this annual review process. At Statistics Sweden, we do have some scientific advisory board to help us for other scientific problems, but not for this one. Right. I understand. What do you think? Maybe so then we can try to have some objective. Maybe different.
That's certainly one way. It actually could go the other way, that if other outside groups, maybe academics or other agencies, see what you're doing, that helps them to think more about the whole statistical process. So you actually could, besides receiving some advice and some expertise, you probably would distribute more of your knowledge outside as well, and it'd be appreciated.
Yeah, it's I'm not sure. It's this review is I'm not sure I can say it, but it's quite basic. Maybe it's not very difficult, but it takes time and quite. I'm not sure other statisticians would like to spend so much time on this. Yeah, but thank you for this suggestion. Yeah. Anyway, maybe we can Steve. We can talk with Steve.
Hello, it's Anna from Paris. Hello, I'd like to ask, maybe I missed something at the beginning, but I don't see well, how do you first determine the population of models you select from?
Okay, I didn't mention it so clearly. Yeah, actually, we use here, we only use the current model and the best 5 models from external ARIMA. Okay. Of course, you can choose other models, but
So I missed this. Thank you.
Yeah.
Hi, I'm Lorena from Ecuador. I have one question. Maybe on the last slide that you had, do you also consider, or have you thought about considering the size of revisions as one of the criteria? Because one thing that happened during the pandemic is that the revisions were slightly higher than in other, let's say, normal times.
Yeah, I do. It's actually our subject staff don't like revision at all. So at our office, we have a quite conservative principle that if the model works fine, we don't need to change it. So I didn't go into the detail. Actually, so we for us, it's perhaps best one of the solution is to raise the weight for revision such that we will choose the same model as long as other diagnostics are not so bad. We do use revision here.